Alright scholars, welcome back to the channel. Today we're going to be looking at writing worded problems as algebraic expressions. So we're often asked to do this before we can solve algebraic problems, right? So you might be given a situation, a scenario, and you must first write it as an expression or an equation before you can figure out what the variables are, what the values of the variables are. You first must put it in algebraic form. So we're going to look at a couple of examples which I'm hoping will help you whenever you have to translate a problem into an algebraic expression or equation. Now for me, algebra is actually my favorite topic in maths. I believe that most problems that I face, I try to reduce it to an algebraic equation. To be honest, you know, the unknown, just let it be x, let it be y, let it be represented by any variable you choose, and reduce the situation to a problem that you can work out, right? And that's how I approach many things in life, and it has worked for me. Now there are certain words that you have to know the meaning of. Remember, I always say mathematics goes hand in hand with the language that you're using. So for us, the language we're using now, here and now, is the English language. You must be familiar with the terms, the actual definition of the terms in English before you can know what to do with them in math. Right? Many mathematical applications are based on what the word means. So let's look at the basic operations, arithmetic operations. So for example, if you are asked to find the sum of a number of terms, that means you're being asked to add them. So words like sum, total, right? In all together, you're being asked to add. If you are told to subtract, minus, take away, you know, those operations mean you use the take away sign, you subtract. Or when you're asked to find the difference. So if they say the difference between x and y, the difference of x and y, that means you're subtracting. Or the sum of x and y, that means you are adding x and y. If you are asked to find the product of the terms, that means you are being asked to multiply the terms. And if you are asked to find the quotient, you are being asked to divide the terms. If they use words like a number times another number, or a number is multiplied by another number, or a number is doubled, tripled, those are multiplication operations. Listen out also for the powers. If a number is raised to a power, if a number is squared, if it is cubed, right? So a number raised to the power of 5, we know that whichever variable we're going to use to represent that number, we're going to put that variable with a little 5 at the right hand, the top right hand, to indicate the power. It's being raised to the power of 5. Now, if you're asked to do more than one operations, a good idea is to bracket the first operation, right? Because the bracket will tell us that we need to work this first before we do the rest. So if you're given a number of different operations, or you have to do this first, and then the result is going to be something, another operation is going to apply to that result, a good idea would be to bracket that first operation, work that, and then you show that whatever else is being done to it, whether it's going to be raised to a power, it's going to be multiplied by something, it's going to be divided by something, make sure it is clear that this is done first. Alright, so pay attention to your brackets. Use up your brackets to indicate to do this operation first. Pay attention to words like The square of the sum of the square, those are two different things. And we're going to look at that. What's the difference between saying the square of the sum of two numbers and the sum of the square of two numbers? Or the difference of the square or the square of the difference? Completely different things we're talking about. So we're going to look at those as well. So let's go through some examples then, right? So we are just going to read what the situation is saying to us. And we're going to express it. Remember, an expression is just saying what it is. You're expressing it in algebraic terms. So we're using up our coefficients, our variables, our powers, our operations, addition, subtraction, multiplication, division. If you missed the first video that I did on algebraic terms, that's the foundational video, the definition of the basic algebraic terms, you might want to get that video, watch it so that you familiarize yourself with these terms that I'm going to be using. 2 times a number x is added to a second number y. Okay, we know that x and y are not numbers, they are letters, but in algebra they represent numbers. They are variables which represent unknown quantities, unknown numbers. So it's all right if we say a number x, a number y, right? We have a little leeway to say that in algebra because that's what algebra is all about. We're using letters to represent unknown numbers. So 2 times a number x, we're going to use x to represent the first number, and they're telling us that we're supposed to multiply the first number by 2. So 2 times x is added to a second number y. Okay? So 2 times a number x is added to a second number y. That is our expression. 2x plus y. 4 times a number p is subtracted from a second number w. Now which one goes first? The p, the 2 times p, or the w? Which one are we taking from which? Do we write w minus 2p or 2p minus w? It says, 4p minus w. It says 4 times a number p is subtracted from, this is the key word here, from. This is subtracted from this. So we start with the w then. And from that we're going to take the 4p. 4 times a number p is subtracted from w. So the expression for that is w minus 4p. The sum of x and 2y is raised to the third power. Now, there are two operations going on there. And remember we said, whenever we have two operations where you have to do one first and then that result, something else is being done, is being applied to that, a good idea is to use brackets. So let's use a bracket to say, what are we doing first? The sum of x and 2y, that's what we're doing first. So x plus 2y, that's the sum of x and 2y. All of that sum, not just the x, not just the 2y, the whole operation of adding x and 2y, that is being raised to the third power. So we have to bracket that and raise all of this. So if we had numbers to plug in for x and y, we'd plug those in, work everything, and that result we would raise to the third power. We'd multiply that result by itself times itself, right, 3 times. The square of the sum of x and y. The square of the sum. Which one do we do first? Do we square them first or do we find the sum first? It's the square of the sum. That means we must have the sum first before we square it. So that's two operations. We're going to use a bracket. to show that we're going to add them first. We're going to find the sum first and then square that result. So this is the square of the sum. The square of the sum. This says the sum of the square. Which do we do first? Do we add them first or do we square them first? The sum of the square. We need to square them first and then find the sum. So we must have the x squared and the y squared and then find the sum. We don't need a bracket this time because we can just express x squared, y squared. We can just put the power to indicate that we are squaring it. And then we're finding the sum. So this is the square of the sum. Totally different thing from the sum of the squares. Okay? Square of the sum of the squares. Let's look at the difference now. Or the cube. This one is the cube. The cube of the sum. So that means we're to find the sum and then cube that sum. So the sum would be x plus y. Sum means we add. And this sum, we're going to raise it to the third power. We're going to cube it. Okay? Same as saying raise to the third power. Cube. We cube it. The cube of the sum. The difference of the square of x and y. That means we're to find the square first and then find the difference of those squares. So that's x squared minus y squared. This is the difference of the squares. The square of the difference of x and y. Now we must find the difference of x and y and then square that. So we need to put a bracket to show that we're going to be finding the difference between x and y, and then when we work that out, we are going to square the results. So look carefully. This is the square of the sum of x and y. The sum of the square of x and y, the cube of the sum of x and y, the difference of the squares, and the square of the difference. It's very important that you know the difference between these things. Alright, so let's look at this one. It says 5 times the number x is added to 8 times the number y, and the result is multiplied by 6. That sounds like we're going to need a bracket because we have to work out this part first, and then that whole result, the result of all of that, not just one part of it is multiplied by the 6. All of that is worked first, and the result is multiplied by 6. So it says 5 times x is added to 8 times y, and the result, so we need to bracket. All of that result is multiplied by 6. That is how we would write that, right? 5 times the number x is added to 8 times the number y. The result is multiplied by 6. The difference of 3 times x and 9 times y is then divided by the sum of 2 times p and 5 times w. That sounds to me like a whole lot of operations. First, we're having some products. Each part of the operation will have a little product to itself, which is that part is simple, right? Like 3 times x, we know that's 3x, so that's not an issue. But we have a difference, we have a sum, and we have a division there. Okay? So we're going to let's use this line to represent the division. Okay? The fraction bar. If you know the fraction bar means divide. Okay. So at the top, what are we dividing by? We're dividing the difference of 3 times x and 9 times y. So 3x minus 9y. That's the difference of 3 times x and 9 times y. That is divided by the sum of 2p and 5w. This is how we write all of that. We didn't need any bracket this time because the division line is saying, we're going to do this, we're going to do that, and then we're going to divide it. We're going to work them out, plug in what we need to plug in, and work them out, and then do the division, right? We can't normally, in order of operation, we know we'd multiply and divide before we add and subtract. The only thing here is the variables, we have to work the variables first. We have to work out the variables and the operation that we're given there, right? And then we would divide them. So, when x is added to a second number y, the result is squared and then halved. When x is added to a second number y, the result is squared and then halved. So x plus y, that result is squared and then halved. What does it mean? What does it mean to halve something? To divide it by 2, right? So we can just put a 2 in the denominator there. So x is added to y, that result is squared, and then that result again is halved. It's divided by 2. You see that? Alright, so we add the x and y, put the bracket to show that we're going to square that result, and then we put a line under all of that to say we're dividing that by 2, we're halving it. To halve something means to split it into 2 equal parts. So we're dividing it by 2. The difference of 16 and x is divided by the sum of 25 and y. Again, we have some separate operations, and then we're going to divide those two results. So the difference of 16 and x is divided by the sum of 25 and y. So this is the difference of 16 and x. This is the sum of 25 and y. And we're going to divide this result by that result. Got it? The last example, thrice. Thrice means it's an archaic way of saying 3 times. It's hardly used anymore, but you still need to know what it means in case you encounter it along your journey, right? Thrice. Thrice means 3 times. So thrice a certain number, b, plus 8 is cubed and reduced by 93. What do we mean by it is reduced by 93? Reduce, check your dictionary. What does the word reduce mean? To make less, right? To take away, to subtract. When you reduce something, you make it less than it was. So, we have a number of operations here. So we say thrice a certain number b. So thrice b, 3 times b, plus 8, all of that is cubed. All of that operation is cubed. Right? Thrice a certain number b plus 8 is cubed. All of this. So we put in our bracket to indicate that we do all of that first. Do all of that first, and when you get the result of here, you cube that result, and then you reduce that by 93. You take away 93 from all of that. So this part must be worked first. You work what's in the bracket. So if you are given the value of b, you multiply that value by 3. You add 8 to it. When you get that answer, you multiply that answer by itself 3 times. You cube it. And finally, you reduce it by 93. You take away 93 from it. And then you will get your final answer. Right? So the language is important. You must make sure you know the meanings of your mathematical terms. Product, sum, total, quotient, difference. Make sure you know what you're being asked to do. If you're asked to double something, that means you're multiplying it by 2. Triple something, you're multiplying it by 3. Right? You're raising something to a power. So if you're raising to the power of 4, you're multiplying that number by itself 4 times. You're not multiplying it by 4, you're multiplying it by itself 4 times. Itself times itself times itself times itself. Right, guys? So check the video on the basic algebraic terms. And if you encounter any other term while you're doing your algebra, grab your dictionary. Your dictionary is your friend. The dictionary is the friend of the mathematician. Right? We are scholars, and so we have to make sure we know what the terms mean that we're using. So if this video benefited you, please drop a comment and say thank you, miss. Please share the video to your friends, neighbors, siblings, cousins, everybody. And if you have not subscribed, please do so now. And let me know in the comments if you want me to do a video on any other topic. I will gladly do that. So I'll see you in the next video. Take care.